Okay, everybody, here we go. Second attempt at this one. We 14.6. Hopefully you'll see new and improved. Got the lights off here and should be focused in a little bit better. Okay, so we have two, remember you only had to do two of the power theorems in 14.7. First one is the two tangent theorem, which basically says that the two tangent segments to a circle from a point in the exterior of the circle. Okay, so here's our circle, here's our point in the exterior of the circle. The two tangent segments would be this one and this one, are congruent, so we're trying to prove that this and this are congruent, and determine congruent angles for the segment from the exterior point to the center of the circle. So in other words, we're trying to prove that this angle and this angle are congruent. Okay, well, how are we going to do that? With all the problems, I want you to, or the proofs here, obviously I want you to try and do it on your own. So pause the video, try and figure it out. When you're ready, then obviously come back in and I'll go through it. So on this one, obviously we can put radii in, and these would be right angles. These are congruent, and then we have hypotenuse. So we have hypotenuse light. And then from that, it would be what? CPCTC times dose. Okay. The two-chord power theorem basically says that if we have two chords that intersect in the interior of a circle, then QS times QR is going to equal QU times QT. I'd love for you to go to page 484. I actually don't have my book here, so I'm not going to be able to do it with you. But go to 484 and see if you can figure out the reasons for the steps in the proof. But by and large, that's kind of what you need to make sure that you know. Okay, so let's practice. So try this one on your own. All right, and I'm back. This is going to use the second of the two theorems. So we're going to basically say that 6 times x equals 8 times 9. So 6x equals 72, which means x is equal to 12. Okay. What in the world is going on with that? Why did that do that? Okay. Let me go bigger. What in the world is going on here? All right, let's do that. That's bigger. Okay. All right, so here we have to find DM and MB. You're also given, I don't think this is on your paper, that BD is equal to 16. So the entire segment is 16. All right, so try that one on your own. There's a little hint on there already for you. But okay, so hopefully you saw that if this is Y and this whole thing is 16, that I could call MB 16 minus Y. Could you do it the reverse way? Sure, of course you could. And then you can use that last theorem. Y times 16 minus y equals 8 times 6, which is 48. So that means when I multiply out, 16 minus y squared equals 48. Yes, you get to use solving quadratics knowledge. So I've moved everything over, set it equal to 0, standard form. And then what does that factor to? Y and y, minus and minus, and 4 and 12. Work. So if I set each of those equal to 0 by the zero product property, y ends up equaling 4 and 12. So what would dm be? Well, it looks here like we would probably want to use the 12 because that looks like the longer part of that segment db. So I would say this is 12 and that is 4. Okay, one other thing to make sure that we're aware of is internal versus external tangents to circles. External tangents do not cross the segment that connects the center of two circles. Okay, so this would be external. Internal does. It goes kind of through the inside of what's between the two circles. That's going to be important to note as we get into some practice problems. Okay, so you have this 14.7 worksheet. I believe you have this in your packet. If you don't, then I'll have to make sure to get you a blank copy. I'll try to remember today when I talk with you guys in a bit. Yeah, we're just under 2 hours away from our first class. All right, so a circle with, again, try these on your own. With radius 8 is externally tangent to a circle of radius 18. find the length of the common external tangent, okay? So think about what that would look like, what you can mark up. Think about, a radius to a tangent and how that forms a right angle. Think about what you kind of figured you might be able to form in there, and give it a shot. Okay, so I'll go ahead and go through it now. Hopefully you figured it out. If you didn't, that's okay. So basically, here's our external tangent. I called it x there. That's what we're trying to solve for. I know that in the small circle, the radius is 8, and it forms a right angle there. I know the radius here is 18. It forms a right angle there. I know that from this point, I can point not on this segment, I can draw in a perpendicular, right? And if I draw in a perpendicular, then all of a sudden I have a right angle, and a right angle, which means that that angle must also be a right angle, and I've formed a rectangle, okay? If I know this distance is 8, and this rectangle right here, isn't this also 8? Yes, it is. What's our goal here? Our goal here is to be able to figure out the common external tangent, which is one of the sides of the rectangle. Which means if we can figure out what this is, then we know that that's congruent to it. Okay, well, how do we do that? Well, if that's a right angle there, I know that's a right angle there. I know if this whole distance is 18 and this is 8, then this is 10. It's not drawn to scale, obviously, right? So you gotta make sure you follow the numbers. I also know that this segment length is 26. How do I know that? Because the circles were externally tangent, meaning that we have a radius here of 18, a radius here of 8, so that adds up to 26. So if you look in this right triangle right here, we have a 10 blank 26 triangle, okay? Now I think over here, because I did this a long time ago and probably not the best way, but anywhere, I had x squared plus 10 squared equals 26 squared, so I did the whole, Pythagorean theorem for no real good reason. It's obviously a triple, right? It's 5, 12, 13 double. But anyway, if you did it, then you didn't recognize that. That's what it would be. Okay, let's go on to the second one. And again, remember, we can always go over these our next class together if you have questions on them. Okay, the centers of two circles of radius 5 and 10 are 13 units apart. Find the length of a common external tangent. Do the circles intersect? Okay, well, what do you think? If the radii are 5 and 10 and the centers of 13 apart, do they intersect? Yes, they do. They definitely do. Okay, so similar kind of strategy for doing this one, and see if you can kind of set this up. I'll do the setup, and then maybe you can go from there. But try doing the setup on your own. Okay, so here we go. I know that the distance is 13. I know that in the smaller circle, my radius is 5. That's perpendicular. I know my radius in the bigger circle is 10. That's perpendicular. I know from the 5 here, from this point, I can draw in a perpendicular to this radius. I know that that forms a right angle, which means this is a right angle because we have right angle, right angle, right angle, and a quadrilateral, which means the fourth angle has got to be a right angle. We have our rectangle right here. So if this is 5, then this is also 5. Well, if this whole radius is 10 and this part of it is 5, isn't this part 5? Yes. Again, is it drawn perfectly to scale? No. Okay, so again, we're looking in this triangle because we're trying to find that. If I can find that, it's going to be congruent to this, so let's try and find that. It's a 5 length 13 triangle there, right triangle. So obviously x is equal to 12. And again, I did Pythagorean theorem work when I really didn't need to. Hopefully you didn't do that. Okay, and there's just some scribbling underneath that, so don't worry about it. All right, number 3. The centers of two circles with radius 3 and 5 are 10 units apart. Are they going to overlap? What do you think? Find the length of a common internal tangent. Okay, so we're doing an internal tangent this time. So I'm going to extend this down a little bit. There we go, so you can see that better. Okay, so think about what this would look like. No, the circles are not going to overlap at all, right? They're not going to intersect because they're 10 apart and the radii are just 3 and 5. All right, so we're trying to find the length of a common internal tangent. So draw your diagram, try and set it up. When you're ready, after you hit pause, come back. Okay, so disregard what's in black here and just focus on the red, okay? Here's our two circles, okay? Here's our smaller one with radius 3. Here's our bigger one with radius 5. I got radii to tangents. Here's our internal tangent. This is what we're trying to find the distance of, right? I've labeled this part of it y. I've labeled this part z. I know that the entire length here is 10, right? 10 units apart. So if I label this part x, I could label this part 10 minus x. Could I go the other way? Of course I could. Wouldn't make a difference. Okay, so what do you notice? What are we going to do next? Look at the two triangles. They're similar triangles, aren't they? We got congruent right angles and we have vertical angles. So yeah, we've got similar triangles by AA. So we can write using a proportion using system, right? And there's many ways we could set it up. I went ahead and set it up as 3 over 5 equals x over 10 minus x. Small over big equals small over big. Okay. And then obviously we could solve for x. So cross multiply, 5x equals 30 minus 3x, 8x equals 30, x equals 30 over 8, which reduces to 15/4. Okay, so how does that help us? We know x is 15/4. Well, won't that allow us to figure out what y is? If I know that the hypotenuse here is 15/4 and one of the legs is 3? Of course it is. So let's see, I did that right here. So 3 squared plus y squared equals 15 over 4 squared. That's obviously 9, which is 144 over 16, because I want to get a common fraction after I square 15 over 4. And then take the square root of both sides. So it's y squared equals 81 over 16. Take the square root of that, and that's 9/4. So I know y is 9/4. Okay. All right, well, we need to now go and figure out what z is. And basically, it's the same type of thing, right? It's going to be z squared plus 5 squared equals 10 minus x squared. I'm sorry, take that back. It's not 10 minus x squared because we know what x is, don't we? And if x is 15/4, then it's what? It's 10 minus 15/4. Well, isn't 10 the same as 40 over 4? And 40 over 4 minus 15 over 4 is 25 over 4. So I've written that in kind of in the black there. So that's 25 over 4. So it's 5 squared plus z squared equals 25 over 4 squared, which is what I have there. If you do the math on that, this becomes 625 over 16. This obviously becomes 25. Well, what's the common denominator there? 16. So 25 times 16 is 400. And you end up getting z squared equals 225 over 16. Take the square root of both sides and you get 15 over 4. So z is 15 over 4. Well, we're trying to figure out the length of the common internal tangent, so we just have to add that and that. So what does that get us? 9/4 plus 15/4 equals 24/4, which is equal to 6. Good problem. Go get a glass of water or pet the dog or something. You deserve it. Okay, here's some interesting problems. These are called walk-around problems. So each side of a quadrilateral ABCD is tangent to a circle, okay? So what does that mean? Does that mean the circle's inside of it? Yes, okay. And we know AB is 10, BC is 15, and AD is 18. So go ahead and label it up. Let me give you a little bit of a hint, right? If we know that there's AB and that's 10, if I label one part of it x, isn't the other part 10 minus x? Okay. And I know BC is 15. Well, if that's x, isn't that x? Didn't we just learn that from an external point to a circle, the two tangent segments to the circle are congruent? Oh yeah, we did. So that's x, that's x. Well, if that whole side is 15, then that's 15 minus x. And basically you can walk around the problem. So give that a shot. All right, I'm back. So if we keep walking around, you would have had 15 minus x. We knew we have to find CD, so I can't really label that. I know that this is 15 minus x because that's congruent to that. But let's come this way. If this is 10 minus x, this is 10 minus x. I know that this side length was 18, AD is 18. So isn't this part right here 18 minus 10 minus x? Which is what? X plus 8. So then I know this part is x plus 8. And then it's, just about going ahead and solving it. So we end up getting 23. Okay. All right. Here we go. Again, another one. Circle P is tangent to each side of a quad. So this one looks a little bit different, right? We have some segment lengths, and we have to find AD. So go ahead and give that one a shot. Alrighty. So if I uncover, that's what we would have to start with. So if I know this side length is 40, I could call this x, this x. This would be 40 minus x. Well, this is 40 minus x. This is 40 minus x. Can't do that part yet, right? Because I don't know what AD is, but I can come back around this way. This is x, and this is 22. This is 22 minus x. This is 22 minus x. If this is all 28, it's going to be 28 minus 22 minus x, which you distribute the negative, ends up being 28 minus 22 plus x, so it's x plus 6, and that's x plus 6 also, okay? So you end up getting what? 46. All right. Circles A, B, and C are externally tangent to each other, okay? So think about what this looks like. And you know that the segments that connect the circles have these lengths, 8, 13, and 11. Go ahead and try and set it up. See if you can figure out to find the radius of each circle. This should be what your setup was, okay? So how did I do this? If I know AB is 8, then if I set this to be x, isn't that 8 minus x? And if this is x, that's another radius right there, right? So that's x, and I know that AC is 11. So how did I get around to that? Well, if I know this is x and this is 8 minus x, that's also 8 minus x. And I know BC is 13, so this is 13 minus 8 minus x, which is x plus 5. So if that's x plus 5, then that's x plus 5. Okay? So how do we go from there? Well, we know x plus 5 equals 11, right? We know that, and that's 11, which means that x ends up being 3. And if x is 3, then what's that radius going to be? It's going to be 8 minus 3, which is 5. And what is this one going to be? Obviously, if x is 3, that's 3. So we end up getting 3, 5, and 8. All right, that does it. Again, remember, you can always go back, watch it again. So review that, and then try the homework problems from 14.7, and we'll go over everything our next time together. All right.